Hello, my name is Jim Siebeking. I'm the Science and Operations Officer in St. Louis. We're going to take a little bit of time today to create a quick video that will review the 4 different probabilistic snowfall data sets that are available for this winter. We'll discuss WPC probabilistic snowfall, WFO ProbSnow, the probabilistic snowfall data from the National Blend of Models, and finally, the probabilistic information that can be created on the fly using model certainty in GFE. Each of these data sets have their advantages and shortcomings. I wanted to thank John Gagan, Phil Schumacher, and Jerry Wiedenfeld for their significant contributions to this presentation. So let's dive in and take a look at WPC ProbSnow. WPC Super Ensemble, also known as the Probabilistic Winter Precipitation Forecast, or PWPF, is composed of 60 models, which are listed here, and then their own deterministic forecast for a grand total of 61 members. They have plans to add a Day 4 forecast to their suite of products this year. Its membership will be a little bit different than Days 1 through 3, as you can see here on this chart, with membership from the GEFS, the EC, and CMC, along with a mean for the 61st member. All of the members of the PWPF can be plotted to obtain a snowfall distribution seen here in green. Then the WPC deterministic forecast becomes the mode of the distribution. Remember, the mode represents the member that occurs the most in the distribution. Once the WPC deterministic forecast becomes the mode, a binormal distribution is constructed, usually resulting in a skewness based on the other members of the PWPF. WPC's ProbSnow guidance is available online, and you're able to display percentile data, threshold probabilities for 24, 48, and 72-hour periods. The WPC guidance is the most robust ProbSnow guidance we have right now, with 61 ensemble members, but it does not take into account the official forecast from the WFO, and it currently only is available for days 1, 2, and 3. The final con, and it's a big one, is that the way the precipitation type is determined is quite crude and based only on mandatory levels. All right, so now let's take a look at the probabilistic snowfall that's created in your office. The first step is that we receive the percentile data and standard deviation information from WPC, and we create a distribution. Then our deterministic forecast becomes the mode, and the probability distribution is adjusted. This can make a big difference. In fact, these 2 graphs provided to us by Phil Schumacher show the Breyer skill score between WPC, the orange bars, and the WFO, the blue bars, for 2 probability thresholds, 2 inches and 8 inches. It should be pretty clear that your forecast as the mode provides a better forecast. WFO ProbSnow can be seen in GFE, and it's posted to our website at least twice a day. The guidance uses the full PWPF from WPC and our WFO deterministic forecast as the mode, so you could say it has 62 members. It, like WPC, is only available through day 3 and has the same crude rain-snow determination for precipitation type. Now let's dive into NBM, version 4.0. NBM probabilistic snowfall is the only guidance that is weighted, but it has a very limited membership at this time, with 25 members through 84 hours and 15 after. Within the first 48 hours, each input uses its own individual sounding to determine precipitation type and snowfall, but after 48 hours, the mean sounding is used along with the mean SLR and NBM QPF. Future NBM versions will become more robust with additional membership. Here's a quick look at how the guidance is weighted in NBM version 4.0. As you can see, only the GEFS and EC mean are used instead of the individual members like WPC and the WFO guidance use. And the membership really drops off after 42 hours. The NBM guidance is available online through the What's Up viewer and the NBM 1D viewer, and will soon be available in AWIPS. The guidance is weighted and available through day 7, but the membership is very limited when you compare it to WPC and WFO. The precipitation type and snowfall calculations are robust in the first 48 hours, but then become more crude with mean soundings used after 48 hours. Finally, let's look at Model Certainty, a tool in GFE. Model Certainty is a powerful tool that allows you to select model inputs, including your forecast, your previous forecast, and the NBM, and make a probability distribution on the fly. While it doesn't have as many members as WPC, its diverse set of processes for obtaining snowfall amounts make its dataset quite dispersive and valuable. This tool allows you to see where your forecast lines up in the broader distribution of model inputs on the fly. The only limitation is that we are limited to the model datasets within GFE. So you may be asking yourself now, great, but which one is best to use? Well, it really depends on the situation. Here's a quick summary slide that should help you remember the advantages and limitations of each of the ProbSnow guidance sets. Just to review, all of the guidance is available for days 1 through 3, but only the NBM and Model Certainty are available for days 4 through 7. The official WFO forecasts included both our ProbSnow guidance and in Model Certainty. WPC and WFO ProbSnow have the most membership with 61 and 62 members respectively. The most robust snow amount calculations are found in the NBM within the first 48 hours and Model Certainty. Finally, Model Certainty is the only guidance where you can, as the user, select the inputs to interrogate. Now for a few examples. Let's say we're looking out in the extended, maybe days 5 or 6, at the threat of a large synoptic winter storm system moving across the CWA. There's good ensemble and deterministic agreement on a favorable track of the system for winter precipitation. Which ProbSnow data sets are available to look at this time range? If you guessed C and D, you're correct. Both the NBM and Model Certainty have probabilistic snowfall data available for days 5 and 6. All right, so now let's say that synoptic winter storm system is expected to impact the region in the next 48 hours. Precipitation type is expected to be all snow due to the Arctic air mass in place across the CWA. You want to get an idea of what the highest snowfall amounts could be within the deformation zone. Which percentile would you focus on? The 10th, the 25th, the 50th or the median, the 75th or the 90th? If you guessed E, the 90th percentile, you are correct. The 90th percentile, or right side of the goalpost, as it often is referred to, is the worst case scenario and represents that only 10% of the guidance is higher than that value. Now let's say a synoptic winter storm system is expected to impact the region in the next 48 hours. Precipitation type, again, is expected to be all snow due to the Arctic air mass in place across the CWA. Which ProbSnow data sets would be the most robust in membership in determining the range of snowfall expected? If you guessed A and B, you're correct. Both WPC and WFO ProbSnow guidance have the most membership, and since precipitation type is not in question, these two data sets would be the best to view at this time range for this example. Now for a few final thoughts. If somebody asks me which ProbSnow data sets do I look at, I would tell them I look at all of them. There's no silver bullet or golden ticket here. The bottom line is that we have 4 data sets that can give us an idea of the range of snowfall, the low end, the high end amount, the skewness of the data, and then we can get a sense of our confidence in the forecast based on where it lies within the distribution. And then we can message that information to the public and our partners. Each data set brings its own approach. When a storm is in the extended, I look at the NBM data sets and use model certainty to see the range of solutions that are available in GFE. Of course, I keep in mind the limitations of the low membership. Then as the storm approaches and the membership increases, more models are available. I track the trends of the guidance, especially at forecast points. And when we get into the range of day 3, where WPC and WFO ProbSnow is available, I start comparing that data to the NBM and the model certainty. Are they all generally showing the same range? If not, why? And then I investigate it further. Is this an all-snow event, or is there some question on precipitation type? Which of these data sets have the most robust precipitation type calculations? Which are just using standard levels and could potentially miss the warm nose completely? The final word of caution I'll give you is this. None of these data sets represent the full suite of model guidance, and therefore they're likely to be under-dispersive to some degree. And every once in a while, your event will fall in that lowest percentile or highest percentile of the distribution, or way outside of the goalposts. It's a rare occurrence, but this is where we as meteorologists have to maintain situational awareness and make the necessary changes to the forecast based on the latest trends. I hope this quick presentation gave you some insight into the different probabilistic snowfall data sets and tools that are out there for you to use this winter. ProbSnow is much more than a product that we run when we're finished with the forecast. These data sets are powerful tools that must be incorporated into your forecast process. Their output can give you a better understanding of the range of solutions, the high and low amounts, the skewness of the data, and where your deterministic forecast will fit into the greater distribution of all the model data. They will help you assess your confidence and better message the forecast to the public and our partners. I thank you for your time, and if you have any questions, please feel free to email me at jim.sieveking@noaa.gov.